This is day 10 of our Leetcode daily question series, and today's question is IPO. In this question, we are given with two vectors, profit and capital, and we are given with two integers also, W and K. And for every capital, we have the corresponding value of the profits, and obviously, so both of the size of vectors of capital and profits will be same. And as we are given initial value of W, which is initial capital, and we can take at most k distinct projects. The projects are defined as we can take one of the profits by doing one of the capital, and after this we have to take another capital, and we after this we have to maximize our final capital. So we will be using a greedy approach to solve this question, as we have to maximize our final capital. For maximizing our final capital, we have to take only those values which have maximum profits, which we can take under W. And the question also says after completing one operation, we will increment our W with the profits of I value which we have completed or added in W. So W will be incremented as W plus equals to profits of I. And there they have also given an example. In this example, as you can see, the profits vector is 1 2 3, capital vector is 0 1 1, initial value of W is 0, K equals to 2, so we can do only maximum two operations, and we have to do two operations of course. And profits is 1 2 3, capital is 0 1 1, initially W equals to 0, so we can take only this value, because we the question says we have to take the value of capital. We can take the value of capital such a way which is less than equals to W at that instance. So we can take only this value 1. After this, W will be incremented as W plus equals to profits of I, so W will be 1, and as W equals to 1, so after this operation we can take both of these values and we will find the maximum profit. So in this case, the result will be 1 plus 3 plus initial value of W equals to 0, which will be 4. Now let's understand the code more efficiently. Let's understand the solution with this question or this example. In this example, we have taken profit as this array and capital as this array, and the corresponding values are written. As for capital 0, profit is 1, for 1 3, 1 4, 2 3 and 1 5. Initially W is given as 0 and K is given as 3. So we have 3 attempts to take 3 profits to add up into our initial capitals. And now let's just first understand what is the brute force approach to solve this question. The brute force approach, as we have K equals to 3, we will find 3 values, 3 profits that are the maximum profits we can take. As initially W is equals to 0, so we will find those 3 profits which we can get with the initial W equals to 0. So we can find only one profit, so we have 1, and now we will add this W in our initial value. So W equals to W plus equals to profit of I, which is equals to 1. So now K will be decremented. So K will be 2. After this, we will again traverse this array of capital and find the corresponding maximum profit that we can get. So for W equals to 1, we have these 3 values, as 0 is already taken. So we have these 3 values which we can get, as we can use only the value which is less than or equals to value in equals to W in this capital array. So we will compare these 3 values and we will get 3 4 5. Now we can sort these values and take the maximum of them and add them into the W. So W will be next equals to W plus equals to 5, which is equals to W equals to 1 plus 5, which is equals to 6. And after this, the K will be again decremented, 2 minus 1, which is equals to 1. And after this, we have K equals to 1, so we want to do this operation again. And as this value is also taken, now for W equals to 6, we have all these 3 values less than equals to 6. So we will take all these 3 values, 3, 4, 3, sort all of them, which will be equals to 3, 3 and 4, and take the longest of all of them. And after taking longest of all of them, we will get 4, and we will add this in our previous value of W. So W equals to 6 plus 4, which is equals to 10, and it will be our final answer. But for this method, we also have to sort both of the array by making pair of them, because if we don't sort, we will have to repeat the process again and again the complexity will be of n square. So we will sort both of these vector by making pair of them and sort them on the basis of capital, and then we can apply this method to solve the question. So our pair of vector will look like this, as we will make the vector of pair with profit and capital. We will put the first value as capital and second as profit, as we have to sort with the capital, and the vector is sorted with the first value of the pair. So the pair will be look like 0 1 1 3 1 4 2 3 and 1 5, and this is our new vector which we have to sort. After sorting this vector on the basis of these values, which are the first values which are capital, we will get the sorted vector like 0 1 1 3 1 4, and now this 1 5 will be swapped here because of sorting 1 5 and 2 3. See, this vector is sorted with the first value of every pair 0 1 1 1 2, and this is sorted in ascending order. Now we can perform this max save operation, and the time complexity of this solution will be O of n log n, because for the insertion of any number or deletion of any element in the heap takes log n complexity, and we will traverse this from left to right, which will take n complexity, and for every element we will take the log n complexity. So the worst complexity will be O of n log n. So as we solve this problem, initially w equals to 0 and k equals to 3, we will run a loop from left to right such that if the initial value is less than or equals to w, we will push the right value, push the profit which we want to extract from the priority queue as the highest element to get the answer. So initially w equals to 0, so if we traverse from left to right, the only this value will be appended in the vector. So 1 will be appended here, and there are no values here, so this value will be popped out and will be added in our initial value of w. So w will be equals to 1. After this I will be initially here and I is now here, our pointer. So I will not go back, I will just only go in the right direction. So we have n complexity, and now as this value is popped out, the priority queue will look like this, and now again doing the same operation, as now value of w equals to 1, so we will again traverse from left to right, and 1 2 3, these three values 3 4 and 5 will be pushed into the priority queue. As the priority queue maintains the descending order, so 3 will be here, 4 will be here, and 5 will be here, and we will get the maximum value which we want to append in the w. So after these three value, w will be equals to w plus equals to 5, which is equals to 1 plus 5, which is equals to 6, and now this value will be popped out. So our priority queue will look like this after this 3 and 4. Remember, these values we have to store, because if this value is less, so this value will be appended and this value will be upper of this, as priority queue maintains the descending order. So after this the value of w is 6, and now our pointer I has reached here, so it will take all this value from left to right. We have only one value, so this 3 will be appended. As this 3 will appended, the priority queue will look like this, as 4 will be here and 3 will be here because of the descending order, and now we will get this 4 to add up to get our final answer. So w plus equals to 4, so w will be equals to 6 plus 4, which is equals to 10, which is our correct answer as we have seen in the brute force approach. Now let's understand how we will code for this particular question. So as I explained, we have to do these following tasks to code. At first we will make the pair, so we will first make pair, and then we have to sort them. So sort the vector of pair, pairs. After this, we have to insert the value in priority queue and increment the values. So priority queue work, and then return our answer. So firstly, we will initialize the values of integer I, which we will take use for our loops, and n, which will be the size of the profits, and the vector capital n equals to profits dot size. Now we will make the pair, so we will just initialize the vector of pairs, vector pair int. This is method of declaring vector of pairs of integer or any variable of any data type, sorry. And now we will run a loop for I equals to 0, I less than n, which is the size of the array, I plus plus. And in this loop, we will push both of the values. Firstly, we will push the value of the capitals and then the profits, as we want to sort on the base of capitals. So we will push the values v dot push back capital I and profits I, as simple as that. And now we will sort this vector. As we have completed make pairs, we will do the next operation, which is sorting. For sorting, we will just use the sort function, which will also take the big of n log n complexity, v dot begin comma v dot end, simple sorting operation. And after this, as we have sorted the pairs, we have to do the priority queue work. And for this priority queue work, initially we will initialize our priority queue of integer data pq. Let's name this pq, and let's initialize I as 0. For while loop, again we will traverse the sorted loop, as we have discussed. We will traverse this sorted loop. So initializing I as 0, and we will increment I later. And so we will do this operation again and again till k will be equals to 0. So we will do this operation for k times. So we will initialize our while loop in such a way, like while k is greater than 0, and in the end of while loop we will decrement k. So this while loop will work only k times, as we want to insert the elements only k times. So let's code while I less than n and vi dot first less than equals to w. Vi dot first is a way of determining the first value of the pair we created, first value of this pair, which will be the capital. So we are writing while I is less than n and vi dot first I less than equals to w. I is less than n is taking the size if the size of the array is completed, so we don't want to push any value in the priority queue. And if vi dot first is less than equal to w, as we have discussed, if this value 111 is all less than equal to w, our current value of w, we will then only push the second value in the priority queue. Otherwise we will not push. We can't push the value 3 here, because this 2 is greater than w. So that's why we are writing vi dot first is less than equal to w. Only this, or if only these both conditions satisfy, we will push the value in our priority queue. pq dot push v of I dot second. Now I am using the second, as we want to push the profits of I. We want to push profits of I in our priority queue. So after pushing this, we will just simply increment our operator I plus plus, variable. And now we will check if pq is empty at the any instance. If the pq is empty, we will break, because if the pq is empty, we can't check the top of the pq. So we will write if pq dot empty break. This statement is for a different edge case, like if the edge case is given like it is given that w equals to 0 and the profit and the capital array is like 1 2 3. This is capital array, and for this instance we can't take any of this value because our initial w is less than capital, so we can't take any of the profit which will be corresponding to these values, so we will just return rw. So that's why we are breaking in this from this while loop, and we will return the value whatever the value of w is at that instance. So let's move forward, and if it is not empty, then we will just increment w by the value pq dot top. As we discussed, we will w plus equals to that value which is at the top of the priority queue. So we will just increment w by this value. This is pq dot top. So w plus equals to pq dot top, or and after this we were just popping out this value. So we will write the operation for popping out, which is pq dot pop, and after this we will decrement our operator k minus minus variable of k, as we will go k greater than 0, and for k minus minus we will only do k operations in this whole while loop. We will only increment w plus equals to pq dot top by k times, and after this whole execution we will return our answer. We will return w. W will be our final answer as we are incrementing all the values in w, and just close this loop. And now this is our final code. Let's submit our code. So our code is accepted. Thank you for watching.